Okay, I wanted to make this quick video to hopefully cement what we learned today in class. So, we have that AG, this line right here, bisects BAC. So, basically angle A. The same thing's going on with the second triangle on the right. I'm just using this color coordination to kind of show you two examples of the proportions that we get and how they're equal. So this first one, we're correlating sides from the different triangles, and we're going to do it like this. I'm going to say this ratio is equal to this ratio, in which case this is one way to think of it. Let's call this triangle 1 and this triangle 2. So in the numerators, we're going to say line segment AC, and then the second triangle, the corresponding side is AB. Right? Those are both the longest sides of each of those triangles. This ratio should be equal to, again, triangle 1, we're going to start with that one, GC, and then the short end of the second triangle, so BG. This is true. This proportion will always be true with a triangle in which you bisect one of the angles. Now, you can also write it like this, the reciprocal of each one, so AB divided by, and I'll write this out, AC. So in this case, we're using the second triangle for our first side length, and then the first triangle for our denominator. So we have to do the same thing with our second ratio. So if we used AB for the numerator, we use BG for the numerator, right? Because they're both from the second triangle. So BG divided by the short side of the first triangle, so GC. Now, if you look, you can tell both these ratios here and this one, the second equality, they're just flipped. They're the inverse, but they're both the inverse, and that's the important point. So you need to make sure you're correlating correctly. Now, let's do this. If we cross multiply, look what we discover. I'm just going to write it in black. So this first one we have AC times BG is equal to AB times GC. The second one, we have AC times BG equals AB times GC. Notice they're exactly the same. So it doesn't matter which you put in the numerator and the denominator, but it matters that you keep it consistent for both of the ratios. So I'm going to erase this real quick. We're going to look at the second triangle. So this is a proportion, an equality of proportions that is always true when we have this bisected angle, this angle bisector. So I'm going to set up these ratios. And in the first one, we're going to use both sides of the first triangle, and then in the second ratio, we're going to use both sides of the second triangle. So the first one's going to be, let's use the long one, A1, B1. So that's this length right here. And we're going to divide it by this length right here. So B1, G1. Then, since we use the long side for the numerator in our first ratio, we're going to use the long side of the second triangle, so A1, C1. Right? Do you see how those correlate? Which means we need to divide that by this length, the shorter one, G1, C1. These should be equal. So just take a look at that and understand how you can use these proportions. Real quick, we'll fly through the most difficult question on the homework. So this wants you to find this length right here, xw. Notice that you don't have either xw or ux, but you know that the sum of them, so this whole length right here, is equal to 10. So let's write that algebraically. Ux plus xw equals 10. Now, I'm going to use this to kind of show, just like in our demonstration a minute ago, that the proportion of these two sides should be equal to the proportion of these two sides. But we have to correlate it correctly, right? So if we put 9/6, which is the long one over the short one, this should be equal to the long one, right? Ux is the longer one, divided by xw. Now, we can use this equation and this equation to solve for xw, which is what we need. I want, in this one, ux on its own, so that when I have ux on its own, I'll have ux in terms of xw. That means I'll be able to substitute this ux for something that's written in xw, so that we have only xw in this equation. Let me show you. I'm going to multiply both sides by xw, because that'll get rid of the xw on that side. Remember, we have to do it to both sides, so this is xw. So we end up with ux is equal to, and I'll rewrite it so that the 9/6 is in front, times xw. Now I'm going to simplify this because this is pretty easy to simplify, right? 3/2. Divide the top and the bottom by 3. You get 3/2 xw is equal to ux. Now, we have ux here. We also have ux up here, right? So what we're going to do is we're going to take what ux is equal to, which is this, and we're going to replace it up here. So we know that ux is actually equal to 3/2 xw. So I'll write let's do it in black. 3/2 xw plus, what is it? Plus xw equals 10. Now, we have like terms, and we can combine like terms. And you'll say, how do we add 3/2 xw to 1 xw? Well, you can rewrite this xw right here as 2/2 xw, right? Because that's equivalent to 1 xw. Now we have a common denominator, so we can add 3 and 2, which gives you 5/2 xw. This is equal to 10, this is equal to 10. And now you solve from here. You'll be able to find xw.